Welcome back, polar bears and polar cubs. It's another chemistry lesson, and this one is over molecular formulas. So it picks up right where we kind of left off with empirical formulas. The only difference is after running an empirical formula, you're going to be able to compare the mass of the empirical formula and the mass of the actual molecular formula. You're going to divide the actual by the empirical. You're going to get a whole number. This whole number is what you're going to distribute to all the subscripts on the elements, and then you'll have your molecular formula. So step one is find the empirical formula. So it could be a two-step problem where you're not given the empirical formula, but you have to run through the math in order to calculate that, and then find the molar mass and divide it by the empirical formula. You're going to round it to the nearest whole number. Don't worry about potential decimals. Okay, and then multiply each subscript by the number found in your previous step. So let's try one. Now, sample problem number one is a little bit simpler, and it gives us the molecular or empirical formula for glucose, CH2O. It tells us then that the molecular formula, after it being CH2O, the molecular formula's molar mass is 180. So we need to find the empirical formula's mass, divide that into the moleculars to get a whole number. So carbon on your periodic table is 12.01 plus 2.02 for the two hydrogens plus 16.00. So you're going to divide, that gives you 3 here. And you add that up, it's a 0, carry the 1 and 3. So it gives you 30.03, which is about 30. So you'll take 180 divided by 30.03, and that'll give you a number about 5.99. So this is pretty much 6. So what I like to do is I put the 6 in front of CH2O, distribute it, make it look like bananas. Do you see the banana? And that's going to give you C6H12O6. And that is the molecular formula for glucose. I'm going to have you guys try the next one. It is a find the empirical and then find the molecular. So 5, 4, 3, 2, and 1. So the first thing that you'll notice within this problem is that they gave you percentages. So that means we need to take a 100-gram sample, and we need to put that over 1. We're then going to convert them to moles using the molar masses based off the periodic table. We're going to then calculate that, divide by the smallest one, which is 3.33, giving us a nice even numbers of 1 C, 2 H's, and 1 O. Our next steps that we need to do is we're going to add up the masses. So we add up the mass, 12.01 plus 2.02 plus 16, 30.03. We're going to see how many times it goes into the 150, which is 5. We create our bananas right here, and then we get C5H10O5. That's all for molecular formulas. If you have any questions, please leave them on the discussion board, and we'll get back to you. Good luck on your